Hi, so this video essentially is going to be like a little supplementary video on how to do a few different Boolean Algebra sort of little tips and tricks essentially, so different types of laws. It's only going to be very quick just so you can sort of help, it'll help work out how to get certain things and obviously how to work out certain parameters of logic gates and what have you. It's pretty straightforward. Hopefully, it should be quite an easy concept to grasp most of this, and then hopefully we should be all right in terms of how the algebra sort of works in terms of breaking it down and stuff. So, without further ado, I'll get straight onto it. So, essentially, I'm going to show you a few different theorems on here. So, what we can start off with, just to sort of show you. So I think I went over this previously, but 1 equaling 1 plus a, I believe. And the reason for this is because these plus symbols are OR gates, and we know that OR gates, if any input is 1, which that's a 1, and that can be anything it wants. It doesn't matter. It can be 0 or 1, then it will always give you a 1 out of it. So that's why when we've had things before where we've had like, brackets 1 plus b or whatever, or less, not b or whatever, it always gives you 1 because this 1 overrides it every time. So that's one quick law for that. But one thing you gotta remember is with the plus being an OR gate, this will always be useful. So this is going to be a useful sort of concept to use when we're doing some of these theorems. So another one, which is quite common for us to use, is 1 equals a plus not a, which is what we've been using before. So this has been quite a common one because obviously we know that that's the opposite of that one. So one of these has to be 1 because obviously the way we do it is a is 1 and not a is 0. And obviously if you all these two together, you're always going to get 1 because one of them's a 1. Now, one concept I want to clear up, just because it kind of doesn't make sense until you look at it properly, but technically, not a can equal 1 and a can equal 0 because a and not a are literally just the opposites of each other. So it just means that the opposite of a, so not a is just the opposite of a. So a could equal 1 and not a could equal 0, or vice versa. So you could have not a equal 1 and a equals 0. So if a starts off as 0, then not a has to be 1 because it's the opposite. So it's really strange because a lot of people are like, I don't understand that concept, but the way I always remember it, just to make it easier for myself and for everybody else, is you always make a 1 and you make not a equal 0 because that makes more sense for me anyway. But as long as you keep to that rule, it doesn't matter unless you're told otherwise. If you're told otherwise in an exam, then yeah, you'll have to do it the other way. But more often than not, they will keep it as that because it makes more sense, and I think it makes more sense anyway. So we've got a few more theorems we can prove. So another one is oops, I don't know why it went like that. A and not a like that. So when they're anded together, essentially, in a Carnot map or truth table, that will always give you 0, because one of these has got to be 0, so that could be 0, that could be 1, or vice versa, as we've just been talking about. So when you AND something together, both inputs have to be 1 to give you an output of 1, so these are going to always give you 0. So if you've got A and not A, that will always give you 0. which is something else that's useful to have. You always want to remember that because that's something that's going to be useful a lot later on when you're doing some of these sort of calculations anyway, potentially. Right. So there's also another one. So we've kind of already done this before, but A and 1 will always give you just what A is. So the reason for that is because if A is 1, then obviously 1 and 1 is going to give you 1, which is what A is anyway to begin with, like this is this one. And then if it's 0 and 1, that's going to give you 0, because an AND obviously will give you a 0 if one of the inputs is a 0. And again, that's A because this is equal to that one. So it's basically saying that A times 1 equals A, which we kind of already knew about, but it's just because they're technically an AND gate that, I was just proving the concept to that, really. There are a few others. So if you had, instead of A plus 1 equals A, if you had A plus 0, that's just going to give you what A is, because obviously if A is 1 again in this scenario, that'll give you 1, and if it's 0 plus 0, that's going to give you 0. So A plus 0 is always going to give you A every time, which kind of seems daft, but that's what it will be. It's just that sometimes you might need this, even though it seems silly. It does make sense as to why you would need this potentially to prove. Like you'd have to prove this potentially at times. So another one, which seems kind of counterintuitive, but A and A itself. So if they're both the same thing, what does that give you? Well, that also gives you A, because if it's 1 and 1, that'll give you 1, which obviously is A, and A. If you've got 0 and 0, that's going to give you 0, which again is, they all have to be the same for that to happen. So A ANDed with itself will always give you itself back. Again, this is quite useful when you're trying to break stuff down. If you ever have an issue where you've got A ANDed together with itself, you can just put it down to 1A. Or you could split it. So if you've got 1A and you need to split it into 2A's like that, then you can, because they're the same thing. So again, another thing to sort of think of in terms of like how to break stuff down, essentially. And again, it should be fairly straightforward, but if you ever get A and then not A together, that's obviously always going to give you 0, because it's A and not A. That kind of makes sense. We've already done that. The other one where it's A and not A, so we've already done this one. Also, that gives you 1. We've been using that one a lot recently. And that is pretty much it for the majority of it. The only other thing that I will say, which can happen, if you have not A, and then for whatever reason you not it again, that will give you A, obviously, because it's the opposite of the not. So if you're not an A, it will make it positive again. Well, make it into an A again, essentially. So just something else to think about. That is pretty much it in terms of the different laws that are available. I said it would be quite quick and quite short. They're literally just some quick laws just for you to have a look at in terms of how stuff works. And obviously you can use them when you're starting to break down stuff. Yeah, I know it's tricky doing some of these Boolean algebra equations just because it's a bit strange conceptually. But once you start sitting down and doing them, it does make a lot of sense when you just think it's just zeros and ones. So that being said, again, if you need any other help with sort of stuff like this, come and let me know. Come and see me at any point in the week or drop me an email. But other than that, try and do some Boolean algebra questions if you can, and revise this a lot because it might be something that you will need. potentially for your exam.